Hello everybody, this is Budrich and yeah, I made this. Here's the level select. I can use the arrow keys here to select the level, and as you can see it updates here the information about how many points you get for 1, 2, 3 lines and a Tetris, and at how many lines you need to advance to the next level. And you can also press A to toggle, and that just toggles here between high and low levels. So for hardcore players, they press A and then run one of these levels, you know. And then you just select it with enter, and then you can play this version of a Tetris-like game that I made in Bash. It is not 100% complete yet. There are some things I would like to do before calling it a day. You know, it would be nice to have, for example, colors. Right now it's only foreground, background color, whatever those are, you know. It all depends on the terminal. Well, maybe I should try to play a game so you can see at least a line clear, you know, and see how it works. And I tried to build this game in like pure Bash. There are just a couple of teapot commands that I use just for convenience. I could as well just write the escape codes that those teapot commands produce. But yeah, it doesn't matter. It is really pure Bash here. Now I have learned a lot of things doing this little project here, and this is actually my second game thing I've been doing this month here. I also made a game of life simulator thing, and after I had done that I thought maybe I can use some of the things I learned here and make yeah, a Tetris block falling like game. There we had some error. I don't know what that is about. As you can see, it is not perfectly complete yet, and there are some weird stuff going on when you rotate blocks and things like that. But I thought maybe instead of me just sitting here alone in my cave, you know, and fiddling with my stupid Bash game here, why not do this together with you guys? And let's make a game. Maybe we should make Tetris, maybe a different game, I don't know. If you have any suggestions, whatever. I thought in this video we can make this. We can make a level select screen. Let's just do this, you know. What do we have here? 10 different levels here. This part. Yeah, let's just make 10 different levels or objects like this that we can navigate with the arrow keys that I'm using here. That should highlight a different object. We can start with that, you know, and just doing that thing will open the doors for some cool things you can do. Let's analyze this a bit, what's going on here. One thing is that we don't have a prompt, we just have a terminal window now. The prompt is gone, the cursor is really gone, and instead we are moving this thing here, but we are abiding all the terminal rules, like only displaying text, and even this black rectangle is of course text. We're using like box drawing characters and things like that. That is the limit we are working with, you know. And in this screen here we are only using foreground, background color. Yeah, let's do this. And I prepared it a bit here. I created a new project called Bud Lanes. It's the Bud Lab Games department. And I created a script called level select, made it executable, but that is all I have done. And we can also, I thought, copy paste some of the code I got here for, I got this init screen here method. Can just paste it here. And then we can do init screen. And what this does is basically turning off the cursor. SM cup, not really 100% sure if it brings the cursor to the top corner, maybe not, I don't know. And clears the screen here. Basically this just clears the screen. So if we would do a read here, or we can do it here, we can see it. And then it also set up 2 traps here. Yeah, we need to make this, actually don't need this resize trap. And if you know your bash scripts, you might see here that I have basically borrowed the functionality here from pipes.sh, which is this Unix porn program, you know, that displays a bunch of pipes. I don't have it installed, but whatever. But this trap is good here, cleanup. So we need a function called cleanup that will get triggered on the hang up signal, terminate signal, exit signal, and interrupt signal. And that is like Control C and stuff, you know. And what we do at cleanup is, I think we can do is teapot reset. I think that's enough. Yeah, let's just do that here. Alright, let's test this. Level select. There, now we just got a blank screen here. If I type something, nothing happens because we don't echo is turned off, so it doesn't echo things back to the screen. We just have a blank terminal canvas, you could think of it as. And we cannot escape, press escape, nothing happens. Only way to get out of this is Control C here, then it will trigger the interrupt signal. And it should trigger this cleanup. Not sure if it did here. Oh, I'm not sure what happened there. Pressing Control C, getting here, pressing Enter, getting here. Let's see what I have in reset, cleanup. Okay, we got a bunch of other stuff here. Let's copy this as well. As you can see, it kind of resets everything, and that's what we want to do. And this is what I meant by not using like 100% pure bash, you know, because teapot isn't really part of bash. It's like a external program, really, you know. But all teapot does really is printing escape sequences, and those escape sequences you could print them using printf, which is built into bash. I think printf is built into bash. Maybe printf is also a separate... No, printf is a built-in shell command. So that's not cheating, and I don't think this is cheating either. Maybe this stty thing, whatever. Now if we run level select, press Ctrl C, it will reset everything back to normal. The only thing is that we will lose all previous information in the terminal, because it will clear the screen here. And that is something, I think you can actually write programs that go into a new screen, so to speak, and then when you exit out of the programs, you will, the old terminal state will be there, you know. But I don't know how to do that. I haven't really looked into it. Just came to think of it now when I started recording this, that is how many other programs. For example, if we do echo hello, and then we can do htop. That is also a terminal program, you know, opens in full screen. I press Q, and then it exits the program, and we got all the terminal. It's like it opens in a new, what to call it, new buffer, new window or something. We're not doing that here yet. Maybe I will look into how to do that, but not today. And also, reason I added read here, if we did remove that and run the script, then you see it just clears the screen, because it when it reaches the end of the script, it sends the exit signal, and then it executes the init screen, or the cleanup function here. So nothing happens. And that is maybe the important thing here today, is to talk a little bit about read. So read, if you just type read, then that means prompt for read input from standard in by default. Let's also comment this guy out now. So now it will not clear the screen or anything. And then we can do echo I have read. Yeah. And now we just get this stupid prompt here. We type stuff, press enter, and then it prints. The read command is finished, and it just prints this. By default, the value you enter to read is stored in a variable called reply, all uppercase. So typing, pressing enter, I have read, value you entered to read typing. So typing is what's stored in the built-in variable reply. But you can also change the name of this variable or use a different name, a placeholder, like placeholder here. If we run the script now, I think we will get the same result. Enter. No, now we don't have any reply here, because now reply is replaced by this variable instead. So now if we wanted to use the value, we have to use placeholder here. Like that. So that's like the simplest version of read. But when you're making a game and want to use read here, what we want to do is react on one key press. And now it just reads here for a line basically. When you press enter, it stops reading. It stops reading on new lines. But if you only want to listen for one key, then you can use n and then the number of characters you want to read, 1. And yeah, that's important. The number of characters you want to read. It's not the number of key presses you want to read. We get back to that very soon here. So now if we try this, level select, and then I start typing something. I will now type something. Well, I just pressed S, and as you can see, the S is printed, and then immediately it echoes I have read here. So we even get the S printed here. And then you have entered to read S. So it immediately terminates when it have read one character. It will stop the read function here. Most of the time you don't want that character printed like that. And then you can use also the silent option, S. So this is really like this, you know. Silent and then the number of characters to read. So now it will not print the S. You can also use T option, and that means timeout number of seconds. So now it will wait. If I haven't pressed the key after 1 second, it will terminate the read loop and placeholder will be empty. Not typing, and then I have read, you have entered to read nothing. Now you see we are getting somewhere. And 1 second is not, you can actually wait. See, here you can use decimal point here to wait for maybe 0.01 second, and that is like 10 milliseconds. So there you can see it just immediately, it felt like, and we can see the execution time here of the whole script was 60 milliseconds. So it more or less immediately ignored this read. And placeholder. Let's type key here instead, since we are reading one key. What we can do here is do a what's called an event loop or main loop or whatever. While colon, or while true, basically, you know, colon, do, done. So this is a loop that will loop forever. And then we can try to read a key here. And then we can make a test. Or maybe this. If key is not empty, then we can do this. And we can say, I'll change this. You entered key. And then we can do press any key to continue. And then we can do a read SM1. You can also type it like this. I think you can type it like that. Maybe you should do that. Like that. And then because, yeah, press any key to continue. This is just an empty read that will not, we only use it to pause the script until we have pressed the key here. Then it will go back into the loop, reading for key presses, timeout after 10 milliseconds, test if we have entered the key. If we did enter a key, it will tell us that. If we didn't, it will go back and read for a new key, whatever. Now it looks like this. We still got the read thing here. I press S. You entered S. Press any key to continue. And then I can press T. And then now nothing happened really, you know, because now it waits for a new key. If I press T again, you enter T. Press any key to continue. I press W. Nothing happens. I press W again. That. Alright. We're getting somewhere. I don't know if how CPU intensive this is. Maybe it's also the recording, but I have really tried to do that as well. I learned that on Game of Life, that you can actually kind of bloat the bash scripts quite a bit doing these things if they are not done correctly. Also, shell check gives us an error here, or a warning that you should not use read without R, because that will mangle backslashes. I'm not really 100% sure what it means, but let's just give it an R so it shuts up, you know. And now we don't get those warnings. I haven't found any like not using R have never caused any issues for me really, except that error message from shell check. And using it haven't caused any issues either. So I always use R here with read. Okay, so if we want to listen for the arrow keys, or let's start with this. Let's use, to make it a little bit simple, you will see soon why this is much easier. Let's use the VI navigation, you know, H for left, J for down, K for up, and L for right. And then we can do a case here. Case key in H. Then we can do D equals left. And then colon, and then we have down, up, right, and then we have an ESAC, and then we have J, K, L, right, up, down, right. And if it's any other key, then we can continue. And what continue here does is continuing the loop, and the loop is here is the closest loop, you know, the while loop. So it will not do anything. It will kind of break out of the case and also start reading a new key. So it will only accept H, J, K, and L keys here now. And then let's skip this guy, and then we can say you direction D or something here. Right, let's run this. Just waits here. I press H, direction left. I press H again, direction left. I press J, direction down. L, right. K, up. And you see it's pretty responsive here. And it's all because this timeout, 10 milliseconds here. You can actually use more decimals here, but I have found that if you make this timeout too short, then you might get weird errors. Like this sometimes just works out. Sometimes it works, but yeah, you can see it kind of works fine here. And you can even hold the key down here. And this is another thing when you're writing games. This key auto-fire or repeat thing here. Here we can see a weird thing. It somehow entered a J here, so sometimes it borks up here when you are, yeah, sometimes it didn't silence the key. And I think that is because we have a too narrow timeout here. But this auto-fire, that is something that you set with X set, I believe, or maybe your desktop environment. It can all kinds of factors factor in, you know, like the speed of the terminal itself. Maybe a game looks fine in your XVT and then I run it in a different terminal. That might change the frame rate, update rate and things like that, and also this auto-fire stuff. So it's not a super fun and friendly game development environment, and maybe you shouldn't write games that care about those things, but whatever, we do that anyways. Okay, we are listening for H, A, K and L, but what if we want to listen for the arrow keys? That's a completely different story. Here's a very useful tip. Go into a terminal and then press Ctrl V. Nothing seems to happen. But now if you press, for example, left arrow here, it will print this. Because Ctrl V, it makes it so that it will print the code for the next character. If I press backspace here now, I press Ctrl V, now I press backspace, we get this. Ctrl V, I press tab, well, then we got a tab. Ctrl V, I press escape, we get this. This is the escape character. Interesting. And we can test the other. Let's do this. So left arrow is this. And then we have, let's do them in the same order as here. J or down arrow is this. Up arrow is this. And right arrow is this. These are the escape codes. And this is actually one character. But this is one character and this is one character. And this means that these keys, when you press the arrow keys, they actually produce 3 characters. An escape character and then like an escape code here, basically. And that escape code consists of 2 characters. And read here, it reads 1 character. So if you press left in this loop here, you will only, this read will only store the first character. So that is something we have to work around to be able to use arrow keys here. So I found a good solution for this. I think I have to cheat a bit here. Yeah, here. Found it on Stack Overflow. Someone who had the same issue here, so I will link this in the show notes. You can even open it here. See what it looks like. Yeah, here is someone who have done this. I modified it quite a little bit, but what it basically does, it does a read 1 character. Yeah, here we can see we also don't need a space between n and 1 here. So it reads one character, and then it tests if that character is the escape character, which looks like this. If it is the escape character, then it read the next two characters. So that means and store those two characters in a variable called mode here. And that means that we can test for up, down, left, and right by using these two last characters. Whatever, I will link this in the show notes. As you can see, it's just a couple of lines. It's just weird, but this is how it works, you know. There is no character for left. What we really do is sending an escape character to the terminal, telling it that we want to move the cursor to the left. And that operation is done by using these escape codes and sending a series of escape characters. And it's the same thing for clearing the screen and everything. That is kind of using the same method. Just happens that some keys on the keyboard produce this escape codes automatically for us. So let's copy this here into our level select. So yeah, now I call this key, so I guess we should do that here. And I wrote it like this, instead of storing this in a variable, I test the value immediately for this \u1b, which is that first escape character here. There are even other ways to write this, whatever. And then it immediately reads the next two keys. That means we got here A, B, D, and C for right, down, left, and right. And if we want to use both H, J, K, and L and arrow keys, we can absolutely do that by just doing this, you know. So either if it's right key or L, whatever, you get it. Let's copy this. Do this, and then we have A, or we don't. We have D, and we have B, and we have A, I guess. Up, and then we remove this guy. And this is also good to use this method here. I have seen others who always do 3 reads and then test if the concurrent reads or contain anything. But here it only does this second read operation if the character is the escape character. Yeah, let's try this. Pressing H, direction left, pressing up arrow, direction up, down arrow, down. And it is pretty responsive and works just fine. Yeah, sometimes it prints and it's always the J, right? Yeah, for some reason it sometimes prints the J here. It's really weird. Whatever. Control C breaks out, and now we don't get any clean screen or anything. Another thing here now, when you're making a game, is that you don't really want to just echo things, because that echo by default, you know, it also suffixes the string with a new line character. That's why we get this scrolling thing after a while, you know. So yeah, we get a new line every time. Yeah, here you can see sometimes the direction leaks out, or the key leaks out. So I think this, let's try this. Let's do this. See if it leaks anything now. Yeah, sometimes it does. I'm not even sure if this is the solution to this issue. Someone knows, please let me know. I'm very new to this. Well, now we don't get anything. Yeah, so it's probably that well, whatever. Well, anyways, we don't want to just print text and create like a gigantically long list of strings here. Let's init our screen here. And then we could also add, let's add Q, and that will clean up and exit. We could even do exit here, because that would also trigger the cleanup function. But whatever. So now we can press Q and that will clean the screen, because now I added init screen, meaning we will not see the prompt or anything. And then it will look like this. I press up, but we still get the text here, you know. Pressing Q, cleans. But what if we wanted to print, just change a single line here, and not print a new line for every time, just we can have the same string, so it says direction, and then it just changes this deed word for us. What we could do is just do echo n. Yeah, let's see what happens now. If we don't suffix it with a new line character. Press up. Now you can see, now we don't got the new line character, but we still, it just prints at the same location all the time. Here is where most people would probably just use teapot. So teapot cup 00. Cup is cursor position, and then it's line and column. So here it will print this thing, and then it will move the cursor position to the top corner of the screen, and that is also where it is when we go into this loop. Now I think it will somewhat work here, and if I press left, press up, it says up, press down, it says down, right, up. You see, it kind of works now, because every time it have printed this line, it moves the cursor back here, and then it prints the line from the same location, just overwriting what's already there. But as you can see, it doesn't work with up, because up is just a 2-letter word, and the other ones are 4 and 5 characters long here. So, but we could work around this by using printf, and then we can make a format string here saying direction, and then percentage, and it's 5 characters, right? 5s. So that will make sure that this string is always 5 characters. If it's less than 5 characters, it will pad it with space. Let's see. Now pressing up, then it says up, and here we can see now it have padded up here with 3 spaces. Pressing right, down, left, up. And sure, this kind of works, but you probably, in this case, don't want to pad it with spaces. Instead, it would be better to have the spaces on the right side of the word. And you can do that by just prefixing the number here with a dash or a hyphen. And now up, left, right. And now we're getting somewhere, you know. But this is what I talked about, and now also if I hold the key, it doesn't look like anything is changing, because it's the same word gets printed over and over. And it actually prints all of these characters here. It prints the word direction, it prints the word deed, it prints everything. So, and that means it needs to update a bunch of characters, needs to do a lot of more work that's actually needed here. What we really only need to do is change the deed word, and the direction could be kept in place, you know. And here you could also use teapot. I guess we should bring up a teapot documentation page or something. Teapot commands bash whatever. There are millions of these pages. Yeah, let's just take one of these. Or this is good. TLDP is a great resource for bash stuff, you know. And Teapot, you can use it for all kinds of things. Changing colors, moving position, and here we have the cup. Save cursor position, restore cursor position. I guess we can use those. Yeah, let's try that. Let's do this. Echo n direction space. And then teapot, save cursor position. Now I think we can just print dir and then teapot restore cursor position. Not sure, I haven't tried this, I don't know why I'm doing this. So now we just say direction, press right, right, and then I press left, left, yes, because now it will. Here I saved the current cursor position, wherever that would be on the screen, print the direction word, and then I restored to the saved position. And since we haven't, it will always be the same position, meaning after the space after the word direction here. Then we don't have to print the word direction, since we already got it, you know. But we could also manually change the cursor position here. CUP, and then we could do like 2, 5. Let's see what happens now. Right, okay. And then I press right again. Now it prints it here. So now this is the second line and 5 columns in. To me it actually looks like the third line here. Ah, maybe it's 0 indexed. The first line is probably 0, 1, line 2. And this is the 5th column or character. So 1, 2, 3, 4, 5. Yeah, and this is also 0 indexed. So it's actually the 6th character is where it will start printing the direction. So this is another way you can do this. But there is actually a fourth or another even better way, because that will not involve teapot here. And that is to use, because teapot, it will produce an escape code. And you can store those escape codes, and then you can use printf to print them instead. Since we are already using printf here, if we would prefix the direction here with the escape code to move the cursor in the printf, that would mean we would use one less command here. And that makes a difference when you're making a game. These things really makes a difference. Especially when you're making like Game of Life, where I updated like sometimes 100 different characters or cells at the same time. Then I could do all of that with one single printf instead of having like hundreds of teapots moving the cursor and stuff. That it made a big difference. And to do that, let's see my level select here, because I don't remember this from the top of my head. Here it is. Yeah, let's copy this. It is not that weird, even if this looks much weirder than it have to be. You can say string here, and here we say x, and here we say y. This is what you want to add to your printf. \E meaning escape character, and then the y position, semicolon, the X position. And Y position is the line number, X position is the column. And then capital H, and then the string you want to print. So if we added this here, like this, and then we could change this to 2 and this to 5. And we don't print this, we don't do this. Pressing up. Maybe it is because I got it here in the format string. We could actually use echo. That's what I also tested, like benchmarked echo and printf, and they are almost exactly as fast as each other. No. Okay, we missed something. We missed something. Echo en \e. It is this square bracket. We need that as well. Yes. Yeah, you see, it's weird. It's not like this is something that you just figure out. This is how you write it. \E, left square bracket, Y position, semicolon, X position, capital H, and then the word, and then it will print that on a certain location. But now we also got the format string thing there. Yeah, because we are doing echo en here, because I'm stupid. We're not doing printf anymore. Now it kind of works, you know. But now it isn't padded with the printf function here. But the really cool thing with this method is that you can add a bunch of different positions after one another here. Let's do this. So, and then we can print the same word at the 5th line, and maybe the 2nd line, but at the 8th column, and maybe the 1st line and 4th column. Pressing left, right, you see it updates several different positions at the same time here. We are using echo and just, yeah, so you get it here. You can update a lot of cells at the same time with just a single command, just modifying this output string here. That is kind of the magic writing somewhat efficient games in Bash, is using this method and trying to do this echo as few times as possible. And even if you want to go really deep, you also don't want to update any unnecessary cell. We get back to that, I guess. Now I don't know how long I have recorded here, because I'm using OBS, and I'm not sure if we can see it here. 43 minutes. Yeah, I guess we make a break here then. This is the intro to the Bud Lames Games series. We are making a game. We haven't done anything useful yet. We still haven't made the level select screen, but that's easy. Now we got the foundation. Now we know our tools here. Let's use these tools to make that level select screen, something like that I showed you in the last video, or whatever, last video in the you know the game, the Tetra Mini is what I have been calling it. Maybe Textris would be a name also, I don't know. But this is what we want to do. Want to be able to move a cursor and select different items like this. And just knowing how to do that, you know, then you could you can make games just by doing that, navigating a maze or whatever. Well, there we see an issue there. Why is this selected here? I don't know. Yeah, it's not perfect. It's not perfect. Nothing is perfect, but it kind of works. Whatever. So, see you in the next video. Like and subscribe. Have a great day. Bye bye bye.